I'm getting better and better. Welcome to my video blog series on mobile applications. Today we're going to look at mobile applications and how they connect to back-end APIs.
Isn't responsive design and HTML5 killing off native apps?
Well, actually, did you know that the predictions that the mobile web would kill off mobile apps has actually been disproven? Some of the analytics data from Flurry and other data gatherers show that games and Facebook apps are actually driving up app use instead.
Mobile apps are great, but they are so much more difficult and expensive to produce. You need iOS specialists, Android developers, integration experts, and to coordinate the three is just a nightmare.
That can be true, but I'm going to show you how we can make a mobile application that connects to enterprise back-end cloud servers in no time at all. Okay, so let's jump in and have a look at Microsoft Azure. What Microsoft Azure is basically a cloud computing platform and infrastructure created by Microsoft. It's for building, managing, and deploying applications and services through a global network of Microsoft managed and partnered data centers. It provides platform as a service and supports many different programming languages, tools, and frameworks, including Microsoft-specific and third-party systems like Java and PHP. Azure was announced in October 2008 and it was released in February 2010 as Windows Azure. It was renamed Microsoft Azure in March 2014. So let's have a look at the Microsoft Azure portal. We have, first of all, a start board, which is in preview. It's new for summer 2015. It's very Windows 10-like. We have a hub menu. We have blades, which are insights, analytics, and entry points. What we're really interested in services, so we're going to jump into the Azure Portal console. So welcome to the Microsoft Azure Portal. If we have a look over on the left, you can see a list of Azure App Services, which are platform as a service environment letting developers easily publish and manage enterprise software onto servers. Starting off with web apps, these allow developers to build sites using ASP.NET, PHP, Node.js or Python, and can be deployed using FTP, Git, Mercurial, or Team Foundation. The blob, table, and queue services can be used to communicate between web apps and web jobs to provide state. Virtual machines enable developers to migrate applications and infrastructure without changing existing code, and they can run on both Windows Server and Linux virtual machines. Mobile services, which we're going to cover a little bit more in detail in a minute, these allow communication, storage, and notification to mobile devices, running platforms such as iOS, Android, Windows 10. Cloud services is a platform as a service environment and can be used to create scalable applications and services. The cloud servers are containers of hosted application. These applications can be internet-facing public web applications such as websites and e-commerce solutions. These are called web roles. Or they can be private processing engines for other work, such as processing orders or analyzing data. These are named web worker roles. Developers can write code for cloud services in a variety of different programming languages, and there are specific software development kits provided by Microsoft for Python, Java, Node.js, and of course .NET. Batch services help run large parallel and high-performance computing workloads in the cloud. SQL databases, formerly known as SQL Azure databases, work to create and scale and extend applications into the cloud, generally coming from Microsoft SQL Server technology. It also integrates with Active Directory, Microsoft System Center, and Hadoop. Storage services provide REST and SDK APIs for storing and accessing data on the cloud. HD Insight is Microsoft's cloud-based Hadoop distribution. We won't go over all the services here, but some other of note are Azure Machine Learning, which is cloud-based predictive analysis and publishing of APIs in the cloud. There's a scheduler, which basically allows you to schedule run tasks in the background. A new interesting feature is Microsoft's remote apps. These deliver Windows applications from Azure, running on Azure, to all kinds of operating systems. OS X, iOS, Android, Windows 10. Remote applications are run on the Windows server in Azure cloud. Application users install an application which contains a remote desktop client on their internet-connected laptop, tablet or phone, and they can access the application with an experience which is pretty much like you're running it locally. So let's take a look at an actual virtual machine. If we choose one here, we can click on Dashboard, and if we let it load, we can see CPU use, disk read, disk write, network out. This is very useful when we're monitoring our virtual machines. However, we'll cover all of this in other videos, specifically on Azure. Let's jump into creating mobile services. Okay, so let's have a look at Azure Mobile Services. Mobile services are basically an API which are web apps running on iOS, Android, Windows 10 are going to contact our back-end logic running on the cloud and make calls. So the best way to learn about a mobile API, a REST API, is probably just to go and create one. So let's go ahead and click on Create a New Mobile Service. Now I'm going to give it a name, Andriod. A database, I'm going to create a new 20 megabyte free SQL database. We're going to choose Northern European region, and that's just because we're in the Northern European region ourselves. For the back end, interestingly, it gives us an option between JavaScript and .NET. So if I was a JavaScript programmer programming my web app in JavaScript, I wouldn't need to learn any other languages other than JavaScript to program the back end as well. Today we're going to choose .NET. There's also an option to configure advanced push settings. Now these are generally to connect to a notifications hub which send messages to a mobile or tablet home screen. However, we're going to cover those in another video. So let's go ahead. Next, it asks me to specify some database settings. Now, the generated database name we're quite happy with, so we're going to keep that. We're going to choose a server. We're going to choose a new database, SQL database server. We're going to make a login name. And we're going to give it a password. And again, for region, we're going to choose Northern Europe. So let's go ahead. We can see the status here is creating. So while Azure is spinning that up, we're just going to be waiting. Okay, so now we can see our mobile service has been created and the status is showing ready. We're going to go ahead and select it. Now in here we can see we have a dashboard similar to what we looked at earlier with virtual machines. And let's go back to the home page where we can see choose a platform. Now this is when you want to develop an app in a specific platform. We have Windows, iOS, Android, HTML, JavaScript, and Xamarin. We're going to choose Android because if we were to choose iOS, we'd need a Mac to emulate and run Xcode. And it's going to be nice and easy to run Android today, having everything on the same PC. So we're going to go ahead and create a new Android app. First of all, you'll need the right tools. You'll need to install Visual Studio Professional 2013. We actually have 2015 installed today. You'll also need to install Android Studio, which installs Java, and it will also set up VMDs, which are virtual devices. To download and publish to the cloud, this is going to allow us to download our API code. So we're going to go ahead and do that. Okay, now we're going to download the C tutorial, and if we open the solution, you can see it's opening in 2015. Give it a second to load. Okay, we can see it's quite similar to a web API project where we have a global SAX, we have controllers, we're looking at our to-do item controller, we also have models and scheduled jobs. So if we have a look at this controller, it's got an initialize function, and then we have basically calls get all to-do items. So this controller is Microsoft sample to-do list. What you can do here is you can get all the items, you can add an item, and you can delete an item. We're going to go ahead and publish this to the cloud. We're going to choose Mobile Azure Services, and we're going to choose from the list, once it loads, Andriod. Okay. Now that should be published to Azure. So now we have a simple API example that mobile applications can connect to.
That's great, but it's not going to be that easy for an iOS or an Android developer to connect to that API code easily.
Well, that might be true, but it's not as hard as you might think. Azure actually generates a scouting project from us for most mobile platforms. Let's have a look at how that works. Okay, so if we go to the URL that we just published to, we can see it's coming up with a HTML page telling us that our mobile service is up and running. So let's go back into the Azure portal and do step 3, download and run our client app. Now because we chose Android earlier, this is going to produce an Android Studio project. So we're going to go ahead and download it. And we're going to extract it to our tutorial folder. Okay, now that it's extracted, we're going to go up and open Android Studio. While it's loading, we can see Android Studio has a lot of the same debugging features as Visual Studio, including an annoying tip. So we're going to wait for the Gradle build to complete, and then we're just going to go straight ahead and run our project and try and emulate it in an Android emulator. So we're going to go ahead and try and run this. Gradle build is still running. Takes a little while. When we're in the choose a device menu, we're going to choose the Nexus 5, which is API version 22, and then we're going to launch emulator. Now, because it takes a little while to launch an Android emulator, we're going to speed things up. Okay, so now our emulator has loaded. Let's swipe to open, swipe to unlock. Oh, just a minute. There we go. Okay, and our Android 2 mobile services application is opened. Now we have a to-do list. We have first item, second item. So let's go ahead and add a new item. Let's call it Andrew's item. Now when I click add here, our app is going to communicate with our mobile API in the cloud, and it's going to add this item to our database. There we go. Now let's try removing an item as well. So I'm going to remove the first item here. So all we can see now is second item and Andrew's item. Now, just to verify things are happening exactly like we expect in Azure, let's have a little look at the management portal. So we have the Android 2 database here, and we have the to-do items table. And if we have a look at the data tab, we can see that, let's refresh the data. Okay, now we can see first item has been completed and is no longer visible as it is shown in our app. We can also see that second item is visible and it's not completed. And we can see Andrew's item has been added to the database by our app. So from that we can see successful communication between the app and our mobile API. So there we have it, a fully working Android application talking to our API in the cloud.
That's cool, but it would be nice if we could change it with some of our own code.
Alright, just to prove it works, let's make some changes from the Microsoft code example and see how that goes. Okay, so let's go back into Android Studio and make some changes. So first of all, what changes are we going to make? One thing that annoys me is when I do something on my to-do list, for a little while, I like to remember what I've done. So let's stop the items being removed immediately. Another thing I noticed was, wouldn't it be nice to have some color in our list? So let's look at making those changes. Go into the Java folder. First we'll go into the to-do activity. This is a class used to create a data table and sync our data with our mobile API. We're going to go down to the check item method. Okay, and we're going to stop our item being removed when it's checked. So we'll just comment that line for now. Next we're going to go right over here and go to our to-do item adapter. This is used to bind a to-do list to a view. And down here in the get view method, we're going to add some color to our list. So let's add alternating color. So an easy way to do that would be to take the position, do what's called a modulus. We're going to do modulus 2. We're going to say equals equals 1. So every other row, odd and even, we can set to different colors. So let's set the first color to be, let's say, set background color, color, almost did the British spelling there, and we'll say yellow. And then we're going to say else Let's set the row, let's set the color to, oops, did the British spelling there. I think I'm mentally disabled when it comes to spelling sometimes. So we'll go for red and yellow. That sounds pretty good to me. Okay, let's go and run our application now. Yeah, again, it takes a little while for the build to complete. So we've already got the emulator running. Let's run it on our existing emulator. Okay, and the application has loaded up. So I'm going to add another item. Indeed, we have red and yellow. Now let's try and check one of these items. Oh, and the item's still there, just like the way I like it. And there we go.
So it's really that easy to produce a mobile app against a cloud API.
Yes, it is. And as mobile platforms grow in popularity and mobile apps grow in popularity, we're going to see more and more people working in this way. That's it, guys. Thanks for watching. Please subscribe to my channel for some up-and-coming mobile blog posts such as mobile authentication and mobile push notifications. For those of you who don't know, push notifications are the notifications that pop up on your tablet or phone's home screen and notify you about events in the application. Thanks for watching.